projects. In this video, we are going to explain about a project titled A Text Classification Methodology to Assess the Large Technical Support System. So now coming to the introduction part. In the domain of extensive technical support systems, proficient handling and resolution of user inquiries are fundamental for maintaining optimal functionality and ensuring user satisfaction. With the escalating volume of user-generated text data in these systems, the significance of robust text classification methodologies becomes progressively vital. This introduction outlines a text classification methodology specially crafted to aid a large technical support system in effectively categorizing and responding to user queries. So now coming to the objective part for this project is to greatly improve the system's efficiency, accuracy and responsiveness in managing user queries. Given the increasing influx of support requests, this methodology aims to tackle the inherent challenges associated with categorizing a wide range of often intricate user-generated text. By harnessing advanced natural language processing and machine learning techniques, the aim is to robust a classification system capable of swiftly identifying the nature of each query, thereby enabling a timely and precise response. So now coming to the requirements part, here we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirements part, Anaconda 3 is required and Visual Studio Community version is required. So now coming to the flow of project. So here in this first we have importing the packages. In this module, necessary libraries and packages which are NumPy, Pandas for data manipulation, sklearn to facilitate machine learning and Matplotlib and Seaborn for visualization are important. Second, here we have loading the dataset news type classification. In this step, you load your dataset which typically contains text data and their corresponding labels for supervised learning. You can use the libraries like Pandas to read the data from a CSV file dataset or any other data source. Then next here we have data processing. Dropping the duplicates. Remove duplicate rows if any exist in the dataset to avoid the bias. Cleaning the text. Cleaning the emojis. Remove emojis from the text data as they might not be relevant for the classification task. And second here in this we have remove the punctuation, links and mention. Eliminate punctuation marks, hyperlinks and user mentions. For an example, @username from the text to focus on the text content. The next here we have cleaning the hashtags. Remove hashtags if they are not relevant to the classification task. Filtering of the special characters. Remove any special characters or symbols that are not informative for the classification. Removing all multiple spaces. Replace multiple spaces with a single space to standardize the text. Visualization using Seaborn and Matplotlib. Data visualization is essential for understanding the dataset and its characteristics. You can use libraries like Seaborn and Matplotlib to create plots, histograms and other visualizations that help in data exploration. Next here we have tokenization using TF-IDF tokenizer. Tokenization is the process of splitting text into individual words or tokens. TF-IDF stands for Term Frequency Inverse Document Frequency. Tokenization is a technique that assigns numerical values to each token based on its importance in the document. It is commonly used for text classification tasks. Then we have feature selection. It involves choosing the most relevant features, that is tokens or words in the case, for your machine learning model. This step can help reduce dimensionality and improve model performance. Then we have splitting the data to train and test. Splitting the data set into training and testing sets is crucial for evaluating the model's performance. The training set is used to train the model while the testing set is used to assess how well the model generalizes to new unseen data. Next here we have building the model. In this step, you create and train different machine learning models for text classification. Based on your list, you may be trying various algorithms that are naive Bayes, a probabilistic classifier based on the Bayes theorem. Next here we have KNN, that is K nearest neighbors, a non-parametric classification algorithm that assigns labels based on the majority class among its K nearest neighbors. Then next here we have MLP1HL. Here it stands for one hidden layer, a feed-forward neural network with one hidden layer. Then MLP2-HL, that is multi-layer perceptron 2 hidden layer, a feed-forward neural network with 2 hidden layers. Random forest, an ensemble learning method that combines multiple decision trees. LSVC, linear SVC, a linear support vector classifier. RSVC, SVC with RBF kernel, a support vector classifier with a radial basis function kernel. Then we have XGBoost, a gradient boosting algorithm, voting classifier, RF plus LR plus ND, a classifier that combines the predictions of multiple base models using voting strategies like hard or soft voting. Then next here we have training the model. After processing the data and selecting features, you proceed to train your machine learning models. Training involves using a portion of your dataset to teach the models to make predictions. You will evaluate and fine-tune the models to achieve the best performance. Then next here we have importing the packages. Similar to the step 1, this step involves importing the necessary libraries and packages for your Python environment. You may use packages like NumPy and Pandas and others for the data manipulation and libraries like scikit-learn for machine learning. Next here we have loading the dataset news type classification. In this step, you load your dataset which contains news articles and their corresponding labels, that is news types or categories. This dataset will be used for supervised text classification. Next we have data processing. In this we have dropping the duplicates. Remove duplicate rows from the dataset to prevent data redundancy. Then we have cleaning the text. In this we include cleaning the emojis. Eliminate emojis from the text as they may not be contribute to the classification. Second, here in this we have remove the punctuations like link mention. Remove punctuation marks, hyperlinks and user mentions to focus on the text content. Then we have cleaning the hashtags. Eliminate hashtags if they are not relevant to the classification task. Filtering out the special characters. Remove any special characters or symbols that do not provide valuable information for the classification. Removing all multiple spaces. Remove multiple consecutive spaces with a single space to standardize the text. Convert to lowercase and contractions. Convert the text to the lowercase for uniformity and expand the contractions for an example like can't to cannot. Then next here we have word embedding and vectorizer text. Word embedding techniques like word2vec or similar methods can be used to represent words in vector form. These words embeddings can be used as features for machine learning models. Vectorization is the process of converting the text data into numerical format that can be used by machine learning algorithms. Next here we have tokenization using W2V tokenizer. Tokenization using a word2vec tokenizer means splitting the text into individual words and generating word embeddings for each word. This method uses word2vec embeddings to tokenize the text, which can capture semantic relationships between the words. Then we have feature selection. Similar to the step 15, this step involves choosing the most relevant features for your machine learning models. In this case, you are working with the word embeddings generators using the word2vec. The next here we have splitting the data to train and test. Divide your data set into two sets, a training set for model training and a testing set for evaluating model performance. This allows you to assess how well your model generalizes to new unseen data. Then next here we have building the model. In this step, you create and generate different machine learning models for text classification. The models you are trying are similar to those mentioned in the previous list. Here in this first we have naive Bayes, a probabilistic classifier based on the Bayes theorem. KNN, K-nearest neighbors, a non-parametric classification algorithm based on the majority class among its K-nearest neighbors. MLP-1HL, multi-layer perceptron, one hidden layer, a feed-forward neural network with one hidden layer. Similarly, for the 2HL, a feed-forward neural network with two hidden layers. Random forest, an ensemble learning method that combines multiple decision trees. LSVC, linear SVC, a linear support vector classifier. RSVC, SVC with RBF kernel, a support vector classifier with a radial basis function kernel. XGBoost, a gradient boosting algorithm. Voting classifier, that is MLP1HL plus MLP2HL plus RF, a classifier that combines the predictions of multiple Bayes models using a voting strategy. Then next here we have training the model. This step represents the continuation of the model training process after feature selection. You can use the selected features to train your machine learning models with the training data. The goal is to optimize the model's parameters and internal weights to make accurate predictions. Next, we have importing the packages. As in previous explanation, this step involves importing the necessary Python libraries and packages for data manipulation, machine learning and other tasks. Loading the dataset news type classification. Similar to early explanations, you load the dataset that contains news articles and their corresponding labels. This dataset will be used for supervised text classification. Data processing. Dropping the duplicates. Remove duplicate rows from the dataset to prevent the data redundancy. Cleaning the text. In this we have cleaning the emojis. Eliminate emojis from the text. Remove the punctuations like links, mention. So in this, just remove the punctuation marks, hyperlinks and the user mentions from the text. Cleaning the hashtags. Remove hashtags if they are not relevant. Filtering out the special characters. Eliminate any special characters or symbols that do not provide meaningful information for the classification. Then next we have removing all multiple spaces. Remove multiple consecutive spaces with a single space for the standardization. Tokenization using count vectorizer tokenizer. Count vectorizer is a method to tokenize text. It converts text data into a numerical format by counting the frequency of words in the text. Each word's count is used as a feature for machine learning models. Then next we have feature selection. Selecting the most relevant features is important to improve model's performance. It involves choosing which tokenized words or features to include in the model based on their relevance to the classification task. Splitting the data to train and test. Just like before, divide the dataset into a training set and a testing set. The training set is used to train the machine learning models, while the testing set is used to evaluate how well the models generalize to unseen data. Then we have building the model. In this step, you create and train different machine learning models for text classification, including naive Bayes, a probabilistic classifier, KNN, k-nearest neighbor, a non-parametric classification algorithm based on nearby data points, MLP1HL, that is multi-layer perceptron one hidden layer, a neural network with one hidden layer. 2HL means a neural network with two hidden layers. Random forest, an ensemble learning method that combines decision tree. LSVC, linear SVC, a linear support vector classifier. RSVC, SVC with RBF kernel, a support vector classifier with a radial basis function kernel. XGBoost, a gradient boosting algorithm. Voting classifier MLP1HL plus MLP2HL plus RF, a classifier that combines the predictions of multiple Bayes models using a voting strategy. Training the model. This is the continuation of the model training process, especially for the model selected in the step 25. You will train these models using the training data and evaluate their performance in subsequent steps. Then importing the packages. This step involves the importing the necessary Python libraries which we have discussed earlier about the NumPy, Pandas, Matplotlib, sklearn and many more. Then we have loading the dataset news type classification. The dataset containing news articles and the corresponding types labels is loaded into a Pandas data frame. Then we have BERT encoding for tokenization. BERT stands for bidirectional encoder representations from transformers, is a pre-trained labeled language model that can be used for various NLP tasks including tokenization. Building the model for vectorizer. A vectorizer is a tool that transforms text into numerical vectors. In this step, a vectorizer is created using the BERT tokenizer. Then we have here label encoding. This step, labels of the news articles are converted into numerical representations using label encoding. Then we have BERT model training and tokenizing the context. The BERT model is trained on the news articles dataset. Once trained, the model is used to tokenize the text of the news articles, converting them into numerical representations that can be used for classification. Next here we have extracting the features to train and test. The feature extracted from the tokenized news articles are split into training and testing sets. The training set is used to train the classification model, while the testing set is used to evaluate their performance. Next here we have building the model. Various classification models are built using different algorithms including naive Bayes, KNN, MLP, multi-layer perceptron, random forest, linear SVC, SVC with RBF kernel, XGBoost, voting classifier that combines MLP1HL, MLP2HL and RF. Next here we have training the model. So here in this, the classification models are trained on the training set of features extracted from the tokenized news articles. Importing the packages, it is similar to the previous step which we have discussed about the NumPy, Pandas and Matplotlib. Then we have loading the dataset news type classification. The dataset containing news articles and their corresponding type labels is loaded into a Pandas data frame. This data frame will be used for training and evaluating the classification models. Then next we have data processing. The news articles are pre-processed to remove duplicate emojis, punctuation links, mentions, hashtags, special characters, and multiple spaces. Next we have tokenization using TF-IDF tokenizer. TF-IDF here stands for term frequency inverse document frequency, which is a statistical measure that reflects the importance of a word in a document. Next we have feature selection. Feature selection techniques are applied to select the most relevant features from the tokenized news article. Then here we have splitting the data to train and test. The feature extracted from the tokenized news articles are split into training and testing sets. The training set is used to train the classification model, while the testing set is used to evaluate their performance. Then we have building the model. Various classification models are built using different algorithms, including Naive Bayes, which we have discussed already earlier, including the models like Naive Bayes, KNN, that is K-nearest neighbor, MLP, multi-layer perceptron, one hidden layer and two hidden layer random forest, LSVC, linear support vector classification, then RSVC, SVC with RBF kernel, XGBoost. Similarly for the voting classifier with the MLP plus MLP1HL plus MLP2HL plus RF. Then we have training the model. The classification models are trained on the training set of feature extracted from the tokenized news articles. Then we have Flask framework with SQLite for sign up and sign in. A Flask web application is created using the Flask framework and SQLite database for user authentication. It handles user sign up and sign in functionality. Next we have importing the packages. Necessary Python libraries are imported for data manipulation, analysis and machine learning such as Pandas, NumPy, sklearn and NLTK. Then we have exploring the data. The dataset containing news articles is analyzed to understand its structure, distribution and characteristics. This helps in choosing the appropriate data pre-processing and modeling techniques. So now next here we have exploring the data. Then we have vectorizer and tokenizing the content. Feature extraction involves selecting relevant information or features from the data to represent it effectively. In NLP, this might involve turning text data into numerical values or features like word counts or TF-IDF values. Then we have building the model. In this step, you choose a machine learning algorithm, example decision tree, neural networks, and configure it. You specify how the model will learn from the training data and make predictions. Then we have user gives input. This is the point where a user provides input or data to the application. In NLP, it could be a sentence or a query. Then we have the given input is translated and pre-processed for the prediction. The input from the user may require pre-processing such as text cleaning, tokenization and other transformations to make it compatible with the model's input data or format. Then we have trained model is used for prediction. The pre-processed input is fed into the trained machine learning model. The model processes the input and generates predictions or responses depending upon the specific application. And the last one here we have final outcome is displayed through front end. The model's output or prediction is presented to the user through a front-end user interface in an NLP context. This might be chatbot response, a translation or any other relevant information. So now coming to the execution part. To execute the project, first we need to open the code folder. So here we have a folder which is named as templates. This folder contains all the HTML pages which is used in the project. It typically includes files like index.html, about.html, etc. which represent different pages of the website. Then we have the folder which is named as static. This folder consists of files related to CSS, JavaScript and Bootstrap files. Next here we have .ipynb file which is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows the users to write and execute code in individual cells, making it a popular choice for data science. Next here we have app.py file which likely contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database and generating dynamic content to be rendered in the HTML template. Next here we have signup.db file. This file appears to be the database file which is used to store the information. So now just click over here and copy the path. Open the Anaconda prompt. Type the cd command followed by a space and just paste the path over here and now hit the enter button. Now type python app.py and now just hit the enter button. After running the app.py file, the Flask framework will host the application link locally at the default address and port 5000 unless configured differently. So here you can see that the link has been posted over here. Just copy this link and paste it into any of the browser. Here I am using Chrome. Just paste the link over here and now hit the enter button. So here you can see that this is our home page for the text classification methodology to assess the large technical support system. By entering your name, your email ID, subject and your message, you can contact with them. You can get in touch with them. You can see that there is a button for sign up. Just click on this button. This is the registration form. Just enter your username, your mobile number, your email, your password for doing the registration. I have already done the registration, so here I am clicking on sign in button. Just enter the username over here and the password which you have created while doing the registration and simply click on login button. Click on OK. And here you can see that you have to enter the message over here for doing the prediction. So let me just enter the text over here. So here you can see that I have entered the text over here and now simply click on predict button. So here by scrolling down below you can see the results for the comment. So the message which I have entered over there is this, and it is showing the label for the message as the text type is force. So depending upon the text or the message you are providing over there, it will detect whether text type is force or something else. Let's click on the about button. Here you can see that there are many different graphs, and based upon the graph we have used many different algorithms which is showing the accuracy over here of these graphs. And here you can see that there is a button for sign out. By simply clicking on this button you can successfully log out with this. So now coming back to the conclusion part. In summary, implementing a text classification methodology for a substantial technical support system marks a notable advancement in the streamlining the management of the user queries. This methodology, propelled by advanced natural language processing and machine learning, tackles the growing challenges associated with the rising volume and intricacy of support requests. So here we have completed with our project. Thank you.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.